Hello and welcome. In this video, we're going to talk about solving quadratics. We're going to focus on three specific methods that we previously learned in Algebra 1 for solving quadratics, which are factoring, graphing, and solving using the square root method. We'll talk about completing the square in the video for 3.3 and the quadratic formula in the video for 3.4. So let's go ahead and jump right in. So in Chapter 2, we talked about what a quadratic is, and a quadratic, when graphed, forms a parabola or a U-shaped or upside down U-shaped graph. And we looked at those quadratics as functions, and we looked at them in a variety of different forms. But we graphed them as a function. What we're going to be doing in this unit is saying what happens if it's just a function, instead of it being f of x equals, we actually have a value that it's equal to, and we're looking for a particular number or x value that would make this true. Well, again, thinking about this as a quadratic and what we want to know, when does this quadratic function equal 0? So what we can do and conceptualize is that if we graph that quadratic function where it crosses the x-axis, that's going to be our solutions. That's going to be where this function is equal to 0. So it's almost like we're solving a system saying, when does this quadratic function, or any quadratic function, when is it equal to, or when does it cross the line y equals 0? For what x values will our output of our function be equal to 0? And if you think about that, that could happen in a variety of ways. This example over here is going to cross the x-axis exactly once, and that's going to be when x is -1. So if I were to graph that quadratic, it would have a vertex that is on the x-axis, which means there would be one real solution. If we look at the quadratic that I graphed over here on the right that's opening upward, this would cross the x-axis twice, which means there would be two real solutions, and those two solutions would be the x values at which we are crossing the x-axis. It's also possible that we have a quadratic that just doesn't ever cross the x-axis, which would mean that there is no real solution because there is no real x value at which we cross the x-axis. And it is important for you to realize that there is no real solution because we are going to talk about imaginary solutions for quadratics later in this chapter. So let's look at the different methods that we can use to solve a quadratic now that we have an understanding of what a solution is. So again, a lot of this should be, or all of this should be, a review from Algebra 1, but what we're going to do in this video is we're going to focus on solving quadratics by graphing, solving them algebraically, and specifically we're going to focus on factoring and using the square root method. And then we're going to extend this a little bit and solve some real life problems. So solutions to quadratics are called a variety of different things. They're called the x-intercepts. That's what we just thought about when we thought about them graphically. They are called zeros, and they are called roots. All of those are different names that are talking about the same basic idea, which, here's a good visual down here, is asking us, where does our quadratic cross the x-axis? So we're going to focus on these three ways to solve in this video, and we will come back and talk about completing the square and the quadratic formula in the videos for those respective sections. So factoring is a great method to use when we can identify that our quadratic equation is easily factored. When I look at something like x squared plus 6x plus 8 equals 0, first of all, I want to make sure it's equal to 0. And then what I have on the left, I want to be able to efficiently factor that. So I know that this could be factored to x plus 2 times x plus 4. And if I can easily factor, then as you'll see in just a minute, we can use the zero product property to figure out that the two solutions to this quadratic equation would be that x is -4 and x is -2. So that's the first thing we're going to focus on. Then we're going to talk about graphing. We're going to review how to graph a quadratic equation or a quadratic function that's in standard form. And we're going to identify from our graph where, if at all, is it crossing the x-axis? Where are those x-intercepts? And then we're going to talk about using the square root method, which is a method that can only be used when either the bx term is equal to 0, or basically when we have a squared term that can be isolated. So if I had x plus 1 quantity squared plus 5 equals 2, as long as I have something that's being squared and I can isolate that, I can get it on one side by itself, then the square root method is going to be the most efficient method to use. So let's go ahead and start by relearning how to solve a quadratic equation by factoring. Okay, so when the left side of a polynomial that is in standard form, when the left side is factorable, meaning we can split this up to be something times something else equals 0, then we can solve this using the zero product property. And what that property says is if I have two things that are being multiplied together to get 0, at least one of those two things has to be 0. So if x times y is equal to 0, then either x is 0 or y is 0. So if I can split this into two sets of parentheses and this left set times this right set is going to be equal to 0, either the left is 0, the right is 0, or maybe they're both 0. But that's the only way to multiply to get 0. That's the zero product property, which says if the product of two expressions is 0, then one or both of the expressions is equal to 0. So I'm actually going to start with number 2 because number 2 is already equal to 0. So what I'm going to do is say, can I look at this and factor this easily? So I know that when I'm factoring, I want my first two terms to multiply to give me the first term, the ax squared term. So what multiplies to give me x squared? X times x. And I know that I want my second two terms inside to multiply to be my c value, which in this case is 35. So I'm looking at 1 and 35 or 5 and 7. I also know that I want those two terms to add to be my middle term, which is going to be 12x. So I'm going to test out 5 and 7. Everything here is positive, so everything here is going to be positive. And then I'm just going to quickly check to make sure that my factoring is correct here. This is 5 times x is 5x. This is 7 times x is 7x. That does give me 12. So good news, we have factored correctly. So this zero product property only works when we're equal to 0 and when the left-hand side factors. So both of those requirements are met. We factored x squared plus 12x plus 35 to be x plus 5x plus 7, and we have 0 on the left-hand side. So now we're going to take each of those two factors and set them equal to 0. And when I do that, I'm going to get, in this case, two solutions. So this is going to be x equals -5. This is going to be x equals -7. And the way that I would like you to write your final answer is using set notation with the smaller number first, and then comma, the larger number. If there's only one number, then inside your set notation, you would just have that one number. If there is no real solution, then you won't have anything inside your set notation. The empty set would be your answer. So if we look at number 1 right now, in the form that it's in, we can't use the zero product property because this isn't equal to 0. But we could move 45, subtract 45 on both sides, so that this is equal to 0, and then we can see if we can factor and use the zero product property. So again, I'm going to ask myself what multiplies to be x squared? Well, that's x times x. And what multiplies to be -45? Well, 1 and 45, or 3 and 15, or 5 and 9. And I know that ultimately I'm trying to make 4. So it seems like 5 and 9 are going to be a good option here. I'm multiplying to get -45, so one of these two things needs to be negative. So I'm going to make my 9 negative and my 5 positive, and then I'm going to check. 5 times x is 5x. X times -9 is -9x. That does, in fact, give me -4x. So my factoring is good. Now I can set each of those two factors equal to 0. And that's going to give me my two solutions, -5, and +9. All right, I'm going to encourage you to pause the video and try and work through number 3 on your own. Make sure that you have it set up so that you can use the zero product property and then solve by factoring. Then unpause the video and see how you did. All right, hopefully you had time to work through that. Before we can use the zero product property, we need to get everything on the left so that we have a product that is equal to 0. Then we're going to factor. This is going to become x plus 8 times x minus 6. And then we're going to set each of those factors equal to 0. And that's going to give us the two solutions, -8 and +6. If you feel like you need more practice on solving using factoring, go ahead and check out the Algebra 1 video on solving by factoring. What we're going to do next is we're going to solve by graphing. So solving by graphing is never going to be the most efficient way to solve a quadratic, especially if you don't have the technology to make a really precise graph. But I do think it's important for us to connect the idea of a quadratic function to a quadratic equation and identify those solutions, and it's a great opportunity for us to review how to graph. So if we have a function that's in standard form, we're first going to find the axis of symmetry. That's going to be x equals the opposite of b over 2 times a. So in this case, the axis of symmetry is the line x equals 1. To find the vertex, we plug 1 in. If I plug 1 in, I get 1 minus 2 minus 3. So my vertex is going to be the point 1, -4. Now you could use the parent function here, since there are no stretches or shrinks, our a value is 1, to just go ahead and finish off your graph here, with the ultimate goal being that we're going to identify the x values where we are crossing the x-axis. We're going to still connect to make a smooth curve. We're still going to have arrows. But if you're struggling to graph using the parent function, what you should do is go ahead and make a table. Put your vertex in the middle of the table. Look at two values below. If I plug in 0, I get -3. If I plug in -1, I get 0. And remember, we can use the axis of symmetry to help us here. If I plug in 2, I get -3, since that's what I got when I plug in 0. If I plug in -1 or 3, I get 0. So however is easiest for you to graph it, the goal ultimately now is to identify from our graph where we're crossing the x-axis. So go ahead and pause the video and work through the same process for number 5 on your own, and then unpause the video and see how you did. So first things first, we can find our axis of symmetry is x equals -1. Now, if I plug -1 in, don't forget to square it. That's going to give me -2 times -1 squared minus 4 times -1 minus 2. -1 squared is 1 times -2 is -2 plus 4 minus 2. This is going to be 0. So our vertex is the point -1, 0, which actually means we already found our solution. Our solution is going to be x equals -1. Now this question says solve by graphing, so we do need to have a fully graphed quadratic there. So you can go ahead and make your table and plug in some points to get the full graph. So once we've made our table and found all our points, we're going to connect our curve. And there we have it. But our final answer is not our graph. We are getting our final answer from our graph, and that final answer is x equals -1. Now, it's not always easy to graph. It's not always possible to factor, so we need more strategies on how to solve a quadratic. So the last thing we're going to do today is look at how to solve a quadratic using the square root method. So in order to solve a quadratic using the square root method, a couple things need to be true. Either there needs to be no bx term, no term that just has an x with it, meaning we have something like ax squared plus c equals 0 or some other number, or we have something that is already squared, or it almost looks like it's in vertex form. Like number 7, if instead of 0 there was an f of x, this would look like it's in vertex form. That's another indicator that we can use the square root method. But if we just have something that's fully in standard form, like 2x squared plus 5x plus 1, that's not going to be able to be solved using the square root method because it doesn't meet the requirements. So if we look at number 6, the term that's being squared, the thing that I want to isolate, is just x squared. So I'm asking myself, what is currently preventing x squared from being by itself? Well, this minus 31 and this 4. So if I'm going to isolate the x squared, I'm going to add 31 on both sides. That's going to give me 4x squared equals 80. And then I'm going to divide both sides by 4. That's going to give me x squared equals 20. Now, to solve for x squared, I'm going to square root both sides of the equation. Anytime you are square rooting both sides of the equation, you need to have a plus or minus there. Now, we need to simplify our radical. There's a couple of ways that we can simplify our radical. We can use the upside down birthday cake. So we write 20, and then we draw a little line like an L. On the outside, we put a prime number that goes into 20. So 20 is 2 times 10. 10 is 2 times 5. This is a square root, so I'm looking for pairs. So x is equal to plus or minus 2, and then what didn't have a pair was my 5. And you can leave it as plus minus, or if you want to, you could split it up into two terms, negative 2 plus the square root of 5. Oops, I guess minus would be smaller. Minus the square root of 5, negative 2 plus the square root of 5. Another way that you could simplify this radical, the square root of 20 is the same thing as the square root of 4 times the square root of 5. Why did I pick this? Because I know what the square root of 4 is. The square root of 4 is 2. So these are Algebra 1 skills that you need to use the strategy that works best for you. What I care about is that you can simplify your radical. All right, number 7 looks a lot different. The term that's being squared is this whole term right here. So in order to isolate that, I'm going to go through the same process. I'm going to add 27 to both sides. And when I add 27 to both sides, that's going to give me 3 times the quantity x plus 3 squared equals 27. And then I'm going to divide by 3, so x plus 3 quantity squared equals 9. I'm going to square root both sides, which means I'm going to have a plus or minus here. And now that actually can be split into two different equations. X plus 3 equals negative 3 or x plus 3 equals positive 3. That's going to give me two solutions, negative 6 and 0. So those are going to be my two solutions. Let's make sure you can see that negative. You also, from this step, could have said x plus 3 equals plus or minus 3. So x equals negative 3 plus or minus 3, which would give us negative 3 minus 3, negative 6, negative 3 plus 3, 0, and you could have gone about it that way. All right, I'm going to encourage you to pause the video and work through number 8 on your own, and then unpause the video and see how you did. Okay, how do we get rid of 4/5 on both sides? We multiply both sides of the equation by the reciprocal, 5 over 4. On the left, that's going to leave us with x plus 3 quantity squared. On the right, that's going to give us 25 over 4. So our squared term is isolated, so we can square root both sides. You can square root 25 over 4 individually, meaning the square root of 25 is 5, the square root of 4 is 2. And then we're going to subtract. Actually, I'm going to set each of these equations up separately. X plus 3 equals negative 5 over 2. X plus 3 equals positive 5 over 2. And I'm going to subtract 3 on both sides. Now, 3 is the same thing as 6 over 2. So I'm going to subtract 6 over 2 on both sides so that I have a common denominator, which makes it easier for me to subtract. And this is going to give me two solutions, negative 11 over 2 and negative 1/2. So the square root method is really efficient. It feels a lot like Algebra 1 where you're just solving for x, but it doesn't work in all circumstances, and that's why we have a variety of different ways to solve an equation. Okay, before we finish off this video, I'm going to introduce one last vocabulary word, and I'm going to have you try 2 problems on your own. So in our last chapter, we talked about intercept form, and we talked about how the x-intercepts are the values that made our function equals 0, which is what we've been talking about in this whole lesson. So we did already mention that another word for the roots are the zeros. We said we could call our solutions zeros or roots or x-intercepts or solutions. A zero of a function is just a value that makes the function equal 0. What I want you to notice is that numbers 9 and 10 look a little bit different because the question actually still has a function here on the left, but the directions say find the 0. So this is assessing that you understand the vocabulary word zeros. All that means is that you're going to rewrite this and set our function equal to 0. And then you're going to solve using any method that you choose. So I'm going to encourage you to pause the video and work through these two problems on your own. You can graph. If possible, you could use the square root method, or you can factor. And then unpause the video and see how you did. All right, hopefully you had time to work through these. The first thing that I notice is that on number 9, we have a greatest common factor in all of our terms. So I'm going to go ahead and factor out that greatest common factor. And then I actually realized that I could divide both sides by this greatest common factor, and then I just have x squared plus x minus 6 equals 0. And I know that I can factor this. This is going to be x plus 3 times x minus 2 is equal to 0, and this is going to be 0 if x is equal to negative 3 or positive 2. Last but not least, number 10. When I look at number 10, the first thing I'm always asking myself when I'm going to factor is, does it factor? Is there a greatest common factor besides 1? And there is a greatest common factor besides 1. Both of these terms are divisible by x, so I can factor an x out. And now it's already in factored form, so I can set each of those factors equal to 0 and get my two solutions of 0 and positive 8. So let's recap what we covered in this video. We started by defining that the solutions to a quadratic, or the zeros, are the x-intercepts where our function, if graphed, would cross the x-axis. We recapped how to use the zero product property to solve by factoring, so factor, as we can see here on 9 and 10, and then set each of those factors equal to 0 and identify your x values. We also talked about solving by graphing, so you're going to graph and then see where your graph is crossing the x-axis. Those x values are your solutions. Or you can solve using the square root method, where you isolate the term that's being squared and solve for x in that way. We want to make sure that we write our final answer in set notation, with the smaller number coming first and then the larger number coming afterwards. So go ahead and write down any questions you have, and I look forward to supporting you on this. Thanks for listening.